Alright, question 3. So this is the same question as before, but it's a slightly different graph. So we've got to crack on, do it. It's a bit long, I know, but if you do it step by step, it's going to be fine. It doesn't take too long. Okay, so we're starting at 1, and end is 7. So 1 is now discovered. Fantastic. Does 1 equal 7? Nope. So we're going to move on and go to the neighbors of 1. What's the neighbor of 1? Well, the neighbors of 1 are 2 and 5. And I want each neighbor of that. So we're going to start with 2. Is 2 discovered? No, it's not. That means we're going to cool with 2 there. So that means we're going to get cooled and go to 2. So we're cooling and going to 2. And now 2 becomes discovered. Fantastic. Does 2 equal 7? Nope. So now we're going to go to each neighbor of 2. What are the neighbors of 2? 3 and 4. Let's start with 3. Is 3 discovered? Nope. So we're going to cool with 3. So that means we're going to go to 3. So let's go down here. Fantastic. We've now cooled. Brilliant. And now we're here. Discovered 3 equals true. Alrighty, here we are. Does 3 equal 7? Nope. So we go through this loop, and I want every neighbor of 3. What are the neighbors of 3? The only neighbor of 3 is 2. Let's go through them. We're now at 2. Is 2 discovered? Yes, it already is. So we check, are there any more neighbors? No. So we finish this for loop, and we jump to this completely explored. That means we completely explore this 3. And we're now completed with this cool, right? We've got nowhere else to go, so we've got to end. So we have to jump back to where we were cooled. Who called us? But 2. So we're going back to 2. Okay. Now where are we? Well, 2 is in the middle of going through all the neighbors. So the next one we haven't done yet is 4. Is 4 discovered? No. So we got to do a cool with 4. Okay. So now we go to 4. And where shall I put 4? Let's put 4 over here. 4 now becomes discovered. And now I'm going here because I'm in this 4 cool, right? Fantastic. Does 4 equal 7? Nope. So I want each neighbor of 4. What are the neighbors of 4? The only neighbor of 4 is 2. So let's start with 2. Is 2 already discovered? Yes. So we skip this and I realize we're out of neighbors. So again, we go to completely explored. That means I completely explore 4. Excellent. And now there's nowhere else for us to go. We've finished this procedure. So we've got to go back to where we were cooled. We've finished. So we've got to go back to where we were cooled. Where we were cooled? Well, we were cooled by this 2 here. So now we're going back to 2 again. Excellent. Now we're at 2. 2 is going through its neighbors. Are there any more neighbors left? No. So that means we're ending this for loop and going this completely explored, which means we're going to completely explore 2. So now I am in this 2 cool, and I've completely explored this 2. And now there's nowhere else for us to go, so we've got to go back to who called us. Well, who called 2? Well, 1 did. So we've got to go back here, back to 1. What was 1 in the middle of doing? Well, 1 was in the middle of going through all of its neighbors. So we're now on to 5. Has 5 been discovered yet? No. So therefore, we call DFS 5. So that means we go to 5. That means we go to 5. We've now gone to 5. Excellent. I can now discover 5. Does 5 equal 7? No, so we're going to move on, and I'm going to go through each neighbour of 5. What are the neighbours of 5? 6 and 7. Let's start with 6. Has 6 been discovered yet? No, it hasn't, so then we're going to call and go to 6. Okay, so call and go to 6. Call and go to 6. I can now discover 6. Oh, that's true. Apologies. It's not 6 and 7. It's 1 and 1, 6 and 7. I missed that out. So the first thing we do is we check if we've done to 1 before. We have already, so then we go to 6. Apologies. There we are. And now we've called 6 and now we're here. Okay, which means I can now discover 6. And that now means this, I can check if 6 equals 7. Does it? No, it doesn't. So we're going to go through each neighbour of 6. What are the neighbours of 6? Well, it's literally just 5. So let's do it. Has 5 been discovered? Yes, it already has. So I've now run out of neighbours. That means we've got to end this for loop, and when we can completely explore this 6. So here I am. I can completely explore this 6. Okay. Now I've got nowhere else to go after this completing the quest, completing the completely explored. So I'm going to go back to whoever called us. Who called us? Well, 5 did, and we were at this 6. Okay, and now we're in the middle of going through all the neighbours. So we went back to 5, and now we've got to see if 7 is discovered. No, we haven't done 7 yet, so we're going to go to 7. And let's do 7. Let's do 7 over here. I can discover 7. And I might need to scroll down a little bit. I can discover 7, so we went through 5, and now I can discover 7. Does 7 equal NV, which is 7? Yes, it does. So we can get there now. Excellent. Fantastic. For each neighbour of 7, we're going to go through. What are the neighbours of 7? Well, the only neighbour of 7 is 5. So we're now going to do that. Here we are at 7. Has 5 been discovered? Yes, it has. So now we're going to end this for loop and completely explore this 7. Okay, and now what do we do? Well, I've run out of stuff to do, so I got to go back to where we were called. We were called by 5 over here. So we're going back to 5. Now we're doing 5. What was 5 in the middle of? Well, 5 was in the middle of going through all of its neighbours. And actually, we just finished the end. So we got to end this for loop, and we go to completely explored, which means we can then completely explore this 5. So here we are in this 5, and we can completely explore this 5 here. Fantastic. Now what do? I've got nowhere else to go, so I've got to return. So I've got to go back to who called the 5. Who called the 5? That means we're going to go back to 1. Okay, so I'm going back all the way to 1. Now here we are. What was 1 in the middle of doing? 1 was in the middle of going through all of its neighbours. Oh, we're fresh out of neighbours. That 5 was the last one, so we've got to again end this for loop and completely explore this 1. And now I've got nowhere else to go, so I've got to return from 1, which is from nothing. So that is when we end.